All right, today we're diving into something really fascinating, a company called DeReticular. They have this, I don't know, almost cyberpunk vision for the future. They're literally taking everyday gadgets off the shelf and, with some incredibly clever hardware hacking, turning them into the building blocks for a whole new kind of decentralized internet. So let's get into how they're pulling this off.
But to really get why they're even doing this, I want to start by asking you a question. Just picture your car on a brutally hot summer day. What do you think is the single biggest fire risk you might just casually leave sitting in there? I bet it's not what you think. Well, it turns out the answer might be the very gadgets you leave sitting on your dashboard. We're talking specifically about things with lithium-ion batteries, like a simple mobile hotspot. Yeah, that little device that's so great for working at a coffee shop. It becomes a serious liability in a more industrial setting. And look, this isn't just some theoretical what-if scenario. DeReticular's own research points this out. Dashboard temperatures in a place like Arizona can just soar past 70 degrees Celsius. That's 158 degrees Fahrenheit. At those kinds of temperatures, a regular old lithium-ion battery isn't just going to stop working, it's going to swell up like a balloon, and that creates a very real fire hazard. So right there, that's the fundamental problem, right? Consumer-grade hardware, it just wasn't built for industrial use. The hotspot you buy for travel can't handle the insane heat of a vehicle's dashboard. That internal battery is its Achilles heel, especially for a piece of equipment that needs to be running 24/7. Now, your first thought might be, okay, so you just buy an expensive, custom-built industrial modem. But DeReticular, they have a much scrappier and, frankly, more brilliant approach. They just hack the hardware. And here's how they do it. It's a beautiful three-step process. First, what they call the bypass. They physically rip out the battery. Fire risk, gone. Second, the dummy. They 3D print this little spacer that houses a circuit to safely step down the power from the vehicle. And third, and this is the genius part, the trick, they solder on one tiny resistor that fools the device's firmware into thinking the battery is there and booting up normally. And just like that, a dangerous consumer gadget becomes the totally fire-safe, industrial-grade Nomad Link. You know, this whole process perfectly captures their entire philosophy, which they also apply to the brains of their mobile units. They take a popular hobbyist board, the Raspberry Pi 5, and they just systematically armor it up. The notoriously unreliable microSD card? Nope, that gets replaced with a vibration-proof NVMe SSD. The fact that it throttles when it gets too hot? Solved. They put it in a full aluminum armor case that basically acts as one giant heatsink. And its fussiness about power? They add safe shutdown circuitry. It's not a toy anymore, it's what they call the RIOS Telemetry Core. So you see, these aren't just one-off clever tricks. These ruggedized, hacked components are the building blocks for a complete, fully integrated product platform that's designed for both mobile and stationary applications. So for their stationary nodes, think a setup for a farm, a rural clinic, or even a home office, they offer the Sovereign Sentry, and it comes in two flavors. You've got a very capable standard model with an Intel N100 chip, and then there's the Pro model, which really kicks things up a notch with an 8-core i3 processor, double the RAM, and double the storage. But here's where it gets really interesting. Take a closer look at that Pro model. Yeah, the spec bump is great, but the real magic is in the software. Why on earth would a piece of infrastructure, a server, need to come with a full suite of hacking tools already installed? Because it's not just one server. It's actually 3 powerful servers running in one box, in what they call the Trinity stack. First, you have the gatekeeper, which is an enterprise-grade firewall that locks down your whole network. Then there's the ledger, which is the part that actually runs the decentralized network and earns you credits. And finally, you get the auditor, a toolkit that lets you constantly probe your own network for weaknesses so you can be sure your node is absolutely rock solid. Okay, so the machine can secure itself, it can even audit itself. But in a truly decentralized system, that's really only half the battle. How do you prove who the human operator is without resorting to something as flimsy as a password? They solve this with a beautiful piece of hardware called the Sovereign Key. So imagine a technician needs to work on a vehicle. No password. Instead, they plug this physical key into a port. The vehicle's computer then issues a cryptographic challenge. Basically, it says, sign this random number for me. The technician just touches the key, and it uses a private key that never leaves that physical device to sign the number. The vehicle verifies the signature, and boom, access granted. It's secure, it's passwordless, and it is totally phishing-proof. So let's just recap. We have hacked, fireproofed hardware, a server that audits itself, and a physical cryptographic key for human identity. I mean, this is an incredibly complex, intricate system. But what's it all for? What's the grand vision here that ties all of these amazing pieces together? The entire goal is to build what they call sovereign infrastructure. It's a network that is owned by its users, that works offline first, and is completely decentralized. The ultimate ambition here is to create, and this is their term, civilization in a box. Resilient infrastructure that can run perfectly fine without ever needing to call home to a centralized cloud server from Amazon or Google. The control is put right back in the hands of the user. And they're proving that this kind of powerful vision can actually be built affordably. That foundational piece of hardware, the hacked, ruggedized Nomad Link that we started with, it retails for just $249. And even at that really accessible price point, this is a sustainable business. After you factor in all the costs for parts and labor, DeReticular is still maintaining a really healthy gross margin of around 40%. It's just a perfect example of how clever engineering creates actual, tangible value. And this financial model, it just scales right across their mobile product line. That rugged Raspberry Pi-based telemetry core, it costs them about $140 to build, and it sells for $299. And when you bundle it all together as a complete mobile kit, they can outfit an entire vehicle with a sovereign, fire-safe, industrial-grade node for $549, all while keeping that same healthy 40% margin. And that's what I want to leave you with, this final, provocative thoughts. DeReticular has basically laid out a blueprint for taking fragile, almost disposable consumer electronics and upcycling them into these rugged, resilient, user-owned tools. So if we can do this for our network infrastructure, what else could we completely rebuild from the ground up?